All right. My name's Alexis. You guys haven't seen me yet this whole semester. So we're just going to start. If you haven't found this yet, it's on ucfstudyunion.wordpress.com. I'm going to post the answers later tonight when I get home. All right. Number 1. Which of these molecules have the highest boiling point? What are we looking for when we're looking for boiling point? Intermolecular forces, right. So let's name them from strongest to weakest. Strongest. Ion, dipole. And LDF. Good. I had extra paper. Okay. So we need to draw out all of these molecules, right? So we have CO2. You have CH2Cl, 2, CH4, and then CH3OCH3, or dimethyl ether. All right, for CO2, what kind of shape is this? Linear. So does this make it polar or nonpolar? Nonpolar. So what intermolecular force does it have? LDF, and only LDF. What about methane, CH4? It will be nonpolar as well, and it'll only have LDF. And what about these two? Polar. They're polar. So what do they have? Dipole, dipole, and LDF. All right, so how can we distinguish which one was stronger? By their molar mass, correct. So which one would have the higher molar mass? CH2Cl2. Cl2 is 35.45 grams per mole, and there's 2 of them, so that's going to make it pretty heavy.
Wait, so why is it heavy?
This one is heavier than dimethyl ether. Are there any other questions? Yeah.
What forces do those two have? I can't see.
Oh, let me move it over. Dipole, dipole, and LDF. And which intermolecular force is present in all molecules? LDF, good. All right, I'm going to give you guys like 30 seconds. All right, is everyone good with number 1? Yeah? All right, number 2. What happens to the vapor pressure of a substance when its surface area is increased at constant temperature? How many people say A? How many people say B? How many people say C? All right, the answer is B. The vapor pressure will remain the same. So I'll read it, but I'll put it up here too. In the bold, it says the rate of vaporization increases with increasing surface area. The vapor pressure of a liquid is independent of surface area. An increase in surface area will increase both the rate of vaporization and the rate of condensation, and the effects will exactly cancel, making the vapor pressure not changing. And this is a question from your textbook that I got, actually. Hi, we're working on a review packet. It's on ucfstudyunion.wordpress.com. It's also right up there too. Oh my gosh. It's on the board, actually. Right here. Oh wait, I don't want to show all the answers. So for those just coming in, we're working on a worksheet that's on ucfstudyunion.wordpress.com, right up here. Now repeat this reasoning. So rate of vaporization increases with increasing surface area. The vapor pressure of a liquid is independent of the surface area, and that's because an increase in surface area will increase both the rate of vaporization and the rate of condensation, and the effects will exactly cancel and the vapor pressure would not change.
Is there an equation that goes along with that?
No, but this is from an explanation in the actual textbook. This is one of those not end of chapter, but end of section questions. All right, so is everyone good with number 2? Question?
How do we know when it says like independent of a liquid? How do we know that the question is referring to a liquid? Like in the explanation, it says the vapor pressure of a liquid is independent.
Mm-hmm.
But is the question, like when it says the vapor pressure of a substance, is that substance a liquid?
It would have to be. If you're talking about vapor pressure going from a liquid to a gas.
Oh.
Yeah. Okay, number 3. I'm going to pull this away. Does everyone have this written down? Yeah? Okay. Number 3. Which property of a liquid increases with increasing temperature? How many people say A? How many people say B? How many people say C? The answer is C, vapor pressure. So thinking about viscosity, for those who said that, they want to know which property of a liquid increases with increasing temperature. If you increase temperature, what is viscosity? The resistance to flow. I'm going to write that right here. So that's resistance of a liquid to flow. So if you increase the temperature, a liquid's going to flow better, right? So that would decrease with increasing temperature. So this one, the answer is C. The other one, the answer is B. This review can be found on ucfstudyunion.wordpress.com. All right, is everyone good with number 3? Yeah.
Do you have any effect on surface tension?
Yeah, I don't think there's an effect with temperature on surface tension. All right, number 4. Which process releases the great amount of heat? So we're looking at condensation of 10 grams of gaseous water, freezing of 10 gases of liquid water, or 10 grams of liquid water, the boiling of 10 grams of liquid water, or the melting of 10 grams of ice. So if you guys remember back to this chapter and the heating cooling curve. What happens at a plateau? A phase change, right. So at the first plateau, you're talking about Q equals N delta H what? Fusion. And then here you're talking about Q equals N delta H vap. If we're going this way, what's happening? You're going from a solid to a liquid. So what type of phase change is that? Melting. And if you're going this way, what phase is this? And then for here at this plateau, if you're going to your right, evaporation. And then backwards would be condensation. All right, so which phase changes are exothermic? Condensation, freezing. So these are exothermic, and this is endothermic. All right, so the question asks, which process releases the greatest amount of heat? Would that be talking about endothermic or exothermic? Exothermic. Exothermic. So we can go ahead and cross out melting and boiling. So now we're left with A and B. So the second part of the question says greatest amount of heat. What is delta H vap? 40.7 kilojoules per mole. And what is delta H fusion? 6.02 kilojoules per mole. So which one would release the greatest amount of heat? Condensation. Yeah, that 40.7 kilojoules per mole. I say remember it. I don't know what the ACS is going to give you. Mm-hmm.
So in other words, any reaction involving gas is going to be taking or costing more energy, right? Just because of the HVAC being a higher number.
Mm-hmm. Yeah.
Conceptually speaking, is it because like, you know, a gas is like so free form and then it like goes back to a more compact thing like a liquid? Is that why it's more?
This is concept. This whole, everything I just did, this is us talking about it conceptually. So the first part of this problem is releases. Or actually, the first thing you should see is that they're looking at different phase changes, and then they're asking about releasing amount of heat. So heat and all of that should have you think of the heating cooling curve. So it would help to draw out the heating cooling curve. Wherever you can find a picture, draw the picture. So then you're thinking, what does release mean if we're talking about heat? So that's exothermic or endothermic. So then you need to figure out which phases are actually exo or endothermic. And then look at the plateaus and think about, oh, what is delta H vap, what's that value versus the value of delta H fusion? So which one would have the greatest effect or the greatest amount of heat being released or absorbed if they asked about which process absorbs the greatest amount? All right, are there any other more questions about number 4? All right, number 5. Consider a substance having a triple point at 885 millimeters mercury and 145 degrees Celsius. If the sample is initially at 175 degrees Celsius and 925 millimeters mercury, what phase transition occurs when the pressure is decreased to 760? So this is another thing. You're reading this and you're like, oh, it would be better if I can make a picture, right? So let's make our picture. What picture am I making? The phase diagram. What is this point? The triple point. And what did they say the triple point is at? 885 millimeters mercury and 145 degrees Celsius. They said your sample is initially at 175 degrees Celsius and 925 millimeters mercury. Does everyone else have this picture? Yeah? All right, so then we want to know what phase transition occurs when the pressure is decreased to 760 millimeters mercury at constant temperature. So your temperature is not changing, but we're decreasing it to about 760. So here we're in solid phase, here we're in liquid, and here we're in gas. So we're starting as a liquid and we're ending as a gas. What phase transition is that? Evaporation. So we're working on the review from ucfstudyunion.wordpress.com. And in the end, I'll let you guys come up and see whatever you missed. And then I'll also put the answers online later tonight.
Will you also be uploading what you do or no?
I don't know how to do that. I don't have a copier. I'll let you come up and you guys can take pictures of my pictures. All right, is everyone good with number 5? Are there any questions regarding number 5? No? Okay. Number 6. Rhodium crystallizes in a face-centered cubic unit cell. The radius of a rhodium atom is 135 picometers, and you want to determine the density in grams per centimeters cubed. What do we know about face-centered cubic unit cells? 4 atoms. And what is your length equal? 2 square root 2r. And just for studying purposes, what about body-centered cubic? And then simple cubic? And they're not going to give you this on ACS. So you guys need to dig deep and remember this. Okay. Yeah.
And that R on the base cube, it's outside the square root.
Yes, it's not part of the square root. Or I used to write it as 2r square root 2. That way I don't mess it up. Okay, so we're starting at 135 picometers. So I'm going to take 135 picometers and get that to centimeters. So we know this is 10 to negative 1, negative 2, negative 3, negative 6, 9, and 12. So there's 10 to the 12 picometers in 1 meter. And in 1 meter, there's 10 to the second centimeters. So this value should equal 1.35 times 10 to negative 8 centimeters. Yeah. It's positive. And when you're doing this, it's negative, but you could have done 10 to negative 12 meters over 1 picometer, or 10 to the 12 picometers per 1 meter. There's way more picometers in a meter. If you want to think about it like that, just ask yourself, is it going to be negative or positive? All right, and so this is our radius. We need to get to length in order to get to volume because it's in centimeters cubed. So our length equation for this would be 2r square root of 2, or 2 times the 1.35 times 10 to negative 8 times the square root of 2. And there you'll get 3.818 times 10 to negative 8 centimeters. So in order to get volume, you're going to cube that value. And you'll get 5.56 times 10 to negative 23 centimeters. Centimeters cubed, thank you. Does anyone have any questions up to this point?
So we got the problem.
Yeah.
Do we have any other information to calculate for density? Or?
Yeah, we're going to get there. You have a question? From here, from the length, or? So the length, after I found picometers to centimeters, I plugged in that equals your radius, because 135 picometers was radius. So I plugged that value into 2r square root of 2. So that's what this is. 2 times, this is our r, times square root of 2. And I got 3.818 times 10 to negative 8 centimeters. Then, in order to get volume, you're just cubing this whole thing. So you just plug it into your calculator and then cube it, and you'll get 5.56 times 10 to negative 23. All right, so is everyone good with volume? Okay, let's continue to get density. So the 135 picometers, the radius, that's the only thing they gave us in the problem. But they also told us it's face-centered cubic. So not only did you guys tell me the length, but you guys told me how many atoms. So how many atoms are in face-centered cubic? 4. So if we have 4 atoms, can we get from atoms to moles? How can we do that? Which is, so we're going to do 4 atoms divided by Avogadro's number, and you'll get moles. Then from moles, we can get to grams, because what is density? Grams per centimeters cubed. So we need to know the molar mass of rhodium. So the molar mass of rhodium is 102.91 grams. And when you plug this into your calculator, you should get 6.835 times 10 to negative 22 grams. All right, so then what would our last step be? Yeah, we're going to divide the grams by the volume. So your density should equal 6.835 times 10 to the negative 22 grams over 5.56 times 10 to the negative 23 centimeters cubed. And your density should be 12.4 grams per centimeters cubed, or B. Why do you keep looking at me like that? All right, is everyone good with number 6? This is highly likely that you'll get a question like this on ACS. There's probably like 4 to 5 math problems from what I heard, and they love a question like this. I'm not saying they are, because I don't know, but I'm saying it's likely. Yeah. Is that good enough or higher? right, does everyone have this work written down? Yeah? Okay. At the end, you can come look at my work after. So, number 7. Which type of solid is dry ice? Let me put the other one so you guys can see. Huh? I know, I'm going to add it. All right, how many people say A, ionic? How many people say B, molecular? How many people say C, atomic? D, metallic? All right, you guys, all you guys were right. It's B, molecular. It's part of the textbook. I honestly don't remember reading, and this is like my least favorite. What?
It says atomic would be just like if it was just.
Yeah, we can write notes actually. Examples. We know ionic has ions, right? So those are all your salts. So ionic is kind of self-explanatory, but we can just write an example. Molecular, what's some other examples besides dry ice? No. I'm thinking of one. Silicon dioxide, is that not one? Sand, yeah. I'm trying to remember the book. It's been a long time since I read that part of the chapter. And that's also glass. Glass and sand, they're the same. Okay. And then what about atomic? Gold, silver. And what about metallic? Those would be like your transition metals or no? Yeah? I'm listening to you guys because I honestly don't remember. But this is at the end of chapter 11, correct? Or 12? It's at the end of chapter 12. So I would go back and literally make those notes because this is a good question to be on ACS. Also my least favorite because I never remember. All right, does everyone have this? I'm going to be very honest with you guys. Like, if I don't know something, I will tell you. I'm not going to sit here and tell you the wrong thing because I don't want you guys to go to your test and be like, dang, Alexis gave me the wrong information. Like, no. I want you guys to do good. So if I don't know it, just go back to your textbook or talk to your professor before the exam. I'm just going to be very honest, okay? I know a lot, but I don't know everything. All right, number 8. Which compound is soluble in hexane? What type of, what was I going to say? What type of molecule is hexane? Before that. What type of molecule is that? What is hexane? A hydrocarbon. It's just a bunch of carbon and hydrogens, right? And we know hydrocarbons are what? Nonpolar. So what intermolecular force does hexane have? LDF. All right, so if we're looking for solubility of something, what are we thinking of? What is that phrase? Great, like dissolves like. So what are we looking for in our answer choice? Not necessarily hydrocarbon, it doesn't have to be, but something that's at least nonpolar and has the intermolecular force of LDF and only LDF. So water, what intermolecular forces is present in water? Hydrogen bond, dipole-dipole, and LDF. What about ammonia? Yes, same thing as water. Propane. LDF. And what about HCl? Ion dipole, dipole-dipole, etc. So what would our answer be? C, propane. I don't think there's any seats next to each other. But there's a seat up here too, and one right here. And this can be found on ucsstudyunion.wordpress.com. Okay, number 9. Which aqueous solution has the highest freezing point? What are our colligative properties? Freezing point depression, boiling point elevation, vapor pressure, lowering, and osmotic pressure. What is that equation that goes with freezing point? The change in temperature of freezing, or freezing point, equals what? I times molality times Kf. And your Kf is going with what? The solvent, right? What does it mean to be aqueous? You're dissolved in water. So all of these solutions are dissolved in water. So would they have all the same Kf? Yes. So we're going to ignore Kf for this problem because they're all the same. Does everyone understand that? Okay. How do we find I? What is I? The Van Hoff factor. And what does that mean? Great. The amount of molecules or ions it dissolves into. So the first one, sucrose. What would the Van Hoff factor be for that? Just 1. What about K3PO4? It will dissolve into what? K plus. How many K pluses? 3. And what? PO4 3 minus. So how many molecules is that? 4. So the Van Hoff factor be what? 4. Are there any questions regarding this? It's sucrose. What is sucrose? It's organic molecule. Do organic molecules break up into ions? No. They're 1. They're not going to disappear. So that's why they'll be 1. So we can write that. Organic molecules, I'll write that right here. Organic molecules, I equals 1. All right, then we have NaCl. What does that break into? Na plus and Cl minus. So the Van Hoff factor would be 2. Great. Then we have MgSO4 2. What does that break into? Mg2 plus and SO4 minus, 2 of those. So what's the Van Hoff factor? 3. So we have 1 times 1.25. What does that give you? 1.25. Then you have 4 times 0.50. Hey. 2. Then you have 2 times 2, 4, and then you have 1 times 3, 3. So what would the answer be? Incorrect. Why? They want the highest freezing point. This is why you guys need to read the problem, dissect. So here it says highest freezing point. Highest freezing point. We already said the colligative property is freezing point depression. So yes, the answer would be C if they're asking for lowest freezing point. But they're asking for highest freezing point, so your answer would be what? A.
So the lower the value of the change of the freezing point, the higher
The freezing point would be. Because the colligative property is in a solution, it will lower the freezing point. So the more, the higher the Van Hoff factor is, or that higher that change in freezing point, the lower that freezing point will be. But if you have a small value, it's not going to change the freezing point as much. So A would have the higher freezing point. It'll still be lower than the actual solution, but it'll be higher in consideration to all of those.
So in this case, if they were asking for boiling point, like what's the highest boiling point, then it would be the higher number?
Yeah, it'll be C, because it's colligative property. All right, so we're learning that it's very imperative that you guys read the question and dissect the problem before you go and answer the question. Because they're not always going to be how you're thinking the question's going to go. And I put this in here purposefully, so that's what I wanted you guys to get it wrong. You learn from your mistakes. Every time I messed up on something, I get it right on the test. So you guys should get this right on the test. All right, number 10. Wait, is everyone good with number 9? Are there any other questions? No? Okay, number 10. What is the vapor pressure of a solution with a benzene to octane ratio of 1 to 2? The vapor pressure at 50 degrees Celsius for benzene and octane are respectively 280 millimeters mercury and 400 millimeters mercury. This is an ACS question. I took it from the book. All right, what is the equation for vapor pressure? No, not Clausius-Clapeyron. P solution or P total equals PA plus PB, right? All right. So we need to figure out how can we solve for mole fraction. They only gave us a ratio, 1 to 2. What does that tell us? Yeah, so we can say there's 1 mole of benzene and 2 moles of octane. What is mole fraction? Mole of A over total moles. So if A was our benzene, what would its mole fraction be? 1 over 3. This would be benzene. And for octane, it would be what? 2 over 3. So your P total would equal 1/3 times 280 plus 2/3 times 400. Are there any questions of how we got to this point? No? All right, so what would our P total be? 360. Question? Good question. So in the question it writes the vapor pressure of a solution with benzene to octane ratio of 1 to 2. So for every 1 mole of benzene, we can say that there's 2 moles of octane. So the mole fraction we know is mole of solvent over total moles. So if it's 1 to 2, we have 1 mole of benzene over 3 total moles. So it'll be 1/3. Trust me, last semester, I didn't even know how to do this. One of my tutees told me, so it took me a while.
So
Yeah.
in other words, you made 1 plus 2
Yes.
equals 3. So
Yeah, 1 plus 2 will equal 3.
benzene and octane to get your total.
And it doesn't necessarily even have to be 1 mole. It's just, that was just giving you the ratio, but it's way easier just to say that's 1 mole and that's 2 moles. Question? Yeah, I did. So P solution equals X solvent over P solvent, or this can equal PA. P solution can equal PA. So I just, to speed up time, I just put that equation here and that equation here. So this is for benzene, and this is for octane. All right, number 11. The osmotic pressure of a solution containing 22.7 milligrams of an unknown protein and 50 milliliters of a solution is 2.88 millimeters mercury at room temperature. And we want to determine the molar mass of the protein. Unfortunately, no. If I had a marker, I would so write on the board. You have a marker?
They're right behind my computer.
Oh, do you guys rather me write on the board? Yeah?
That would be awesome.
Okay, so this is our white paper. I'm gonna write right under it. Is there an eraser? Yes. What number is this? 11. So what's the equation that we're using for osmotic pressure? What is our R? And then our temperature, it's at room temperature. So what is that in Kelvin? 298 Kelvin. And then molarity, what is that equation? Moles of what? Solute over liters of solution. All right, so we have 2.88 millimeters mercury. We cannot leave that as 2.88 millimeters mercury. Why not? Yes, because our R is an ATM, you need to have everything in the same unit. So you have 3.789 times 10 to negative 3 ATM equals, we can ignore the I because it's an unknown protein. We can just assume that it's 1. So then I'm just going to do molarity. So you have moles of your solute over liters of solution. And that's times your 0.08206 multiplied by 298 Kelvin. This board's not even, but okay. All right. So then when you put all of this in your calculator, you should get 1.5496 times 10 to negative 4. This is equal to your moles of solute over your liters of solution. In the equation, or in the problem, they told you that the unknown protein is in 50 milliliters of solution. So that is equal to 0.05 liters. I guess they're still doing construction. Okay, So then your moles would be 7.7482 times 10 to negative 6 moles. And what are we trying to get to? Molar mass. What is molar mass? Grams per mole. And what do they give us for our grams? 22.7 milligrams. Because it's an unknown protein, and they didn't tell us that there's a Van Hoff factor, we can assume it's 1. So our molar mass should equal 2.27 times 10 to negative 2 grams, all over 7.7482 times 10 to negative 6 moles. So your answer should be 2.93 times 10 to the 3 grams per mole. Is this perfect? Yes.
Next time you do the calculations, could you just space them out a little bit more?
Sorry, I didn't want to go all the way down because the back wouldn't be able to see. I didn't plan very well.
No, that's okay. We tried. That's what
All right, so number 11 is C. There's a C somewhere up here and here. And this is being live streamed, so if you miss something, you can go back on YouTube tonight and watch. You can also watch last year's. You can also watch my very first one, but I wouldn't suggest doing that. It was like 3 years ago. It was awful. But yeah, I have a couple of them up there. So if you just go to UCF SARC YouTube's page, you can watch them and look back. And I'm also going to post these answers later. All right, are there any questions from my math?
Where did you get the 22.7
Milligrams? They told you in the problem. Right here. Mm-hmm.
After you got 7.7482, where did you go from there? Yeah.
I just went from, so I just found the molar mass here. We got the grams from doing 22.7 milligrams divided by 10 to the third milligrams. So that's the grams divided by that same value to get you the molar mass, grams per mole. Okay, we're only at number 11. There's 50 problems, so yeah. Is everyone good with this? I want to erase.
you can always watch back.
Yes, you can always go back to YouTube and slow me down if I'm going too fast. All right, number 12. This is actually from the textbook. So if you don't understand, you can go back and read it. I literally got it from one of those end of chapter problems. But if each solution listed here costs the same amount per kilogram, which would be most cost effective as a way to lower the freezing point of water? And we're going to assume the complete dissociation for all ionic compounds. All right, so the answer for this, I'm just going to tell you. The answer is B. It wouldn't be A because A is not ionic. But B, however, is ionic. Comparing NaCl, KCl, MgCl2, and SrCl2, what do you guys notice about NaCl? They're all salts. It's one of the smallest ones, right? Out of all of them, it has the smallest molecular weight. So this would be the most cost-effective because, one, it's ionic, so you have to pick whichever one's ionic, and it will be cost-effective because we're talking about per kilogram. This is the smallest weight. So your answer would be B.
So that has nothing to do with something being better at lowering.
Yeah, no.
What about the Van Hoff factor and how, in our last problem we did, the Van Hoff factor affects the freezing point?
Yeah, that's affecting freezing point. Yes, all of these are affecting freezing point, but we're looking for cost-effective. They're not asking what would lower it the most. They're just asking what would be cost-effective to even lower the freezing point. So 12 would be B. All right, any other questions?
Is the ACS like that?
Yeah.
Sorry to ask, but why couldn't be C?
We're looking for cost-effective. So smallest. Yes. The lowest molecular weight. They're all ionic, so you had to pick which one was ionic. And then you got to think about it. We're talking about per kilogram. So you need to look for the one that's the lowest molecular weight. They're not asking you which one's going to lower it the most. They just want to know, we just want to lower it. Does that make sense? Okay. Number 13. Ooh, one of my favorites. What is the rate law of the following reaction? How many people say A? I'll give you 2 seconds.
Oh, I know this one.
How many people say A? How many people say B? How many people say C? How many people say D? The answer is D. Can you determine rate law from this?
No.
No, it has to be done in an experiment. The only way you can find rate law is if it's experimentally found.
But you could find K with just.
Nope, you cannot find anything with just this.
Why couldn't you find K?
It needs to be done experimentally. I have another problem where they do it experimentally, number 15, but number 14.
You said it was D, right?
Yes, it cannot be determined. Number 14. Dinitrogen monoxide decomposes into nitrogen and oxygen when heated. All right, so dinitrogen monoxide decomposes into nitrogen and oxygen when heated. The initial rate of the reaction is 0.022 molar per second. What is the initial rate of change of the concentration of N2O? You guys want me to use the board? So let me use the board. Is that good? I can barely see, but it's okay. So we know rate equals -1/2 change in N2O over change in time equals +1/2 change in N2 over change in time equals +1/1 change in O2 over change in time. But they're only talking about this part right here. They give us the rate to be 0.022 molar per second, and this equals this. The question is asking for the initial rate of change of the concentration of N2O. The initial rate of change of N2O is this. So in order to get that, you'll just multiply this by -2. So it will be -0.044 molar per second. And your answer would be C.
So when they say rate of reaction, they mean
The whole reaction. That's the initial rate of change. Rate of change is that. This is rate of the reaction. Question?
Multiply the other side by 2.
Negative 2. Mm-hmm. It's just basic algebra now. If you just think about this whole thing as x. No, this is multiplied by negative 2. I should say all right, is everyone good with this? Can I erase? Okay, number 15. Yeah, I definitely need to do the board for this one. Okay, this is what I mean by you have to determine it experimentally. This is an experiment. So for the reaction 2A plus B to C, the initial rate was measured at several different reactant concentrations. From the tabulated data, we want you to determine the rate law of the reaction. No, you have to. So for the first one, to find the order with respect to A, I'm going to use trials 2 over trial 1. So you have 0.10 over 0.05 raised to the m. Then you have 0.05 over 0.05 raised to the n. And that equals 0.070 over 0.035. I'm just looking at the table. And I'm doing trial 2 over trial 1. That's all I did. I just rewrote it. All right, so 0.10 divided by 0.05 is 2. 0.05 over 0.05 is 1. 1 raised to anything is what? It's 1. So we can ignore this. And then you have 0.070 over 0.035. That's 2. 2 raised to the what will equal 2? 1. So far, our rate law looks like this. What is this? A raised to the 1. Now to solve for B, I'm going to do the same thing and pick 2 trials. For B, I did trial 3 over trial 2, I think. So I did I did 0.20 over 0.10. We found m to equal 1. So then I'm going to put 0.10 over 0.05, raise that to the n, and that would equal 0.56 over 0.070. So again, I just put trial 3 across the board on top, trial 2 on the bottom. .2 divided by 0.1 is what? So 2 to the 1 is 2. Then you have 0.10 divided by 0.05. 2 to the n. And then 0.56 over 0.070 is equal to 8. So we want to divide both sides by 2 so we can get 2 to the n by itself. So you have 2n equals 4, and 2 to the what will equal 4? 2. So then you can add B raised to the 2. So what would your answer be? C. Are there any questions regarding number 15? Can I erase the board? So number 16. A decomposition reaction has a half-life that is independent of its initial concentration of the reactant. What is the order of the reaction? How many people say A? What? How many people say B? How many people say C? How many people say D? The answer is B, first order. First order is independent of its initial concentration of the reactant. What is the half-life of first order? 0.693 over K. It's the only one where they don't care about the concentration. And if you don't know any half-life, I'd say remember this one. Like, most definitely. Yeah. I said if you can't remember any formula, make sure you remember this one. I mean, you should remember everything, but like realistically speaking, with everyone else's exams, you probably won't remember it, but you should remember this one. All right, 18. A plot shows the rate of the decomposition, or I'm skipping. Number 17. Which statement is true regarding the function of a catalyst in a chemical reaction? Yes, the answer is D. A catalyst does increase the rate of the reaction. It does so by not being consumed by the reaction and also by providing an alternate mechanism for the reaction. So these are all true. Yeah.
The catalyst isn't consumed in the reaction.
No.
That was a part of the reactants.
No, it's part. Yeah, it's part of the reactants. Like I can't think of any. Or I could. You have A plus B yields C, and then you'll probably have. Let me just say C plus D. Then you have like C plus E yields A plus F, something like this. I'm just making this up. But A is here. A catalyst is present as a reactant and as a product, but it's not consumed in the reaction. Which one of these would be an intermediate?
So when you think about
C.
you're thinking more of like the overall reaction, so everything at the end.
A catalyst is present in the reaction. It doesn't get used up at all. Like it's not reacting with anything. Yes, it's there as a reactant, but it's not actually reacting with B. Does that make sense? Okay, so A would be a catalyst, and then B or C would be an intermediate, if they ask you a question like that. All right, 18. A plot shows the rate of the decomposition of SO2Cl2 into SO2 and Cl2 as a function of 1 over concentration of SO2Cl2. What is the order of this reaction? Yeah, second order. So you have, let's just draw all of them. You have concentration of A versus time. This is zero order. Which way does the line go? Negative slope. Then you have what for first order? You have ln A, negative slope versus time. Then you have 1 over concentration. For second order, what does the slope look like? Positive K. So this is negative K, this is negative K, this is positive K. And those are, the K's is the slope. They also can give you the graphs and just have you pick one. So they can either write it in a sentence or they can actually give you the picture. Yeah, the ACS. I'm just going to leave it up there, but move on to the next question. So a reaction in which A, B, and C react to form products is first order in A, second order in B, and zero order in C. We want to know by what factor does the reaction rate change if A is doubled, B remains the same, and C is tripled. So they're basically saying rate equals K times A is what? Second or first, B is second, and C is 0. C is 0, so it technically isn't there. So they want to know by what factors the reaction rate change if A is doubled. So that's basically by saying A is times 2, and B remains the same. If you want to remain the same, that would be like saying you're 1. So 2 times 1. By what factor would this increase? By a factor of 2. You can also say, for another problem, if we just switch it around, and they said A remains the same and B doubles, what would it increase by a factor of? 4. So they can mix this all up, and you guys can create like a bunch of problems from this. But yeah, for the practice exam I gave you guys, the answer is A. All right, 20. The half-life of a sample is 4.12 days. How long will it take for 75% of the sample to decay? If 75% of the sample decays, how much of the sample is left? 25%. So if you're starting at 100%, what happens after one half-life? 50%. And what about a second half-life? 25%. So is this not 75% decayed? What does a half-life equal? 4.12 days. So you have 4.12 days, and then you have another 4.12 days to give you a total of what? 8.24 days for 75% of the sample to decay.
So when they ask what decays, you have to basically look at how much is left.
Mm-hmm. Or they can say, how long will it take for 75% of the sample to still be there? And that would be less than 4.12 days. You just have to really read the problem and understand it. Okay, the next question. I want you to consider the following rate mechanism. What best describes AB subscript 2? AB subscript 2. Intermediate, correct. So the answer for 21 is C. Mm-hmm. Something that is made and directly consumed. All right. I want you to express the equilibrium constant for the following equation. We said D? C? Yeah, the answer is C. It's going to be K will always equal concentration of products raised to their coefficients over reactants raised to their coefficients. And what two phases do you not include? Solids and liquids. All right, number 23. Consider the following reaction at equilibrium. You have calcium carbonate yields calcium oxide and CO2. So what is the effect of adding additional CaO to the reaction mixture? How many people say A? How many people say B? How many people say C? D? I heard you guys whispering the answer. Yeah, it's D. Why is it D? It's a solid. What do we not include in equilibrium? Solids. Yes. So that will make your answer D. Does everyone understand number 23? Yeah, if it was a gas and we were to add more CaO, okay, if this was a gas and we were to add more CaO, then it would be like this, and you want to shift it to the left in order to make that seesaw balanced again. Yes.
And if it was a liquid also, it wouldn't matter.
Yes, liquids would not affect equilibrium. Bless you. Okay, number 24. Consider the following reaction at equilibrium. You have 2 KClO3 at equilibrium with 2 KCl and 3 O2. What would be the effect of decreasing the volume of the reaction mixture? Yes. So if you decrease the volume, what is that effect on pressure? It increases the pressure. So if you're increasing the pressure, you're decreasing the volume. Think about it. You're stuck on an elevator. Would you rather be stuck on an elevator with a bunch of people or like no one? No one. So we want to go to the side with less what? The less moles of gas. So what side has less moles of gas? The reactants. And that'll be shifting to the what? The left. So you want to shift towards your reactants. When you're talking about volume. If you're talking about volume or pressure. Where's my pen?
If volume has increased, then you want to shift to the right.
Yeah. Yeah, if volume were to have increased, it would mean this big room. Would you rather be at a party with more people or less people? More people. So this one, 24, is B. All right, 25 we can do. There's one problem in here. 29 I'm skipping because I realize it's a quadratic, and you won't have that on your test. 29 we're skipping.
Alexis?
Yeah.
For 24, when would the answer be no change for 24?
It would never if they're talking about volume or pressure.
Like if you were like to decrease the volume of like a gas or a liquid, it would still shift to the.
It'll be a gas. So always go to the less moles of gas. Okay, 25. Consider the reaction between NO and Cl2 to form NOCl. A reaction mixture at a certain temperature initially contains only NO and Cl2. They give you 0.50 of those. So basically, they're asking for, they're looking for Kc, so you have to do what? Starts with an I, ends with an E. An ice table. This one's not bad. I promise. All right, so we're going to make our ice table. So initially, we have 0.5 molar of this and 0.5 molar of this. And at equilibrium, we have 0.3 molar of NaCl. So that means we have none of this initially. All right, so if we're starting at 0 initially and we're going to 0.3 molar, what does that change? Positive 0.3 molar. You went from 0 and you're going to 0.3. All right, so you have a 2 to 2 ratio, mole ratio. What would be the change here? Minus 0.3 molar. It's the same value, 2 to 2, 1 to 1. So this would be 0.20 molar. Then here, what would be the change? Yes, minus 0.15, because this mole ratio is a 1 to 2. So you're going to have to half this value to get this change. So 0.50 divided by, or subtracted by 0.15. And you get 0.35. We know our K is products raised to their coefficients over concentration reactants raised to their coefficients. So if we're trying to find our Kc, we should have concentration of NaCl squared, NO squared, Cl2. So then you're just plugging in those values. You have 0.3 squared over 0.20 squared times 0.35. And this will give you your Kc. Mm-hmm.
The exponents you're putting there because of the coefficient, right?
Yes. You need to remember to raise these to their coefficients. So your Kc, you guys should get when you plug this in, is C, 6.4. Are there any questions regarding this? Is everyone good with this? Yes? I can move on? All right, number 26. Which one of these is a weak acid? B. All right, 27. Which pair is a Bronsted-Lowry conjugate acid-base pair? What is that definition? Bronsted-Lowry definition for acids. Acids donate protons, and bases accept proton. So which one of these would be a Bronsted-Lowry conjugate acid-base pair? A. All right, are there any questions regarding this one? Question or no? Yeah. That's Lewis. So Lewis, we can write that right now too. So your Lewis definition, your Lewis acids do what? Accept electrons. And your bases do what? Donate electrons. With Lewis, you have to draw it out and actually look at their Lewis structures. When you're looking at their Lewis structures, what are you looking for on a base? Lone pairs. So I'm going to write that next to it. All right, is everyone good with this? Yes? All right, 28. A nitric acid aqueous solution has a pH of 1.75. What is the molar concentration of the HNO3 solution? All right, so we're looking for molar concentration, right? And this is what type of acid? Strong acid. So if your pH equals 1.75, how can we get to concentration of H plus? 10 to the negative pH. So your H plus concentration should be 10 to the negative 1.75. So what do you guys get for that? 0.018 molar, or D. What type of acid is HClO2? Weak acids. What do weak acids do? Yes, partially dissociate. So what do you have to do with weak acids? An ice table. So you have HClO2, and you want to put that weak acid in water. And when you do that, what do you have as their products? All right, so initially, what do we have? And 0, and then you're going to minus x, so you have 0.155 minus x, plus x, x, and x. So then your Ka will equal x squared over 0.155 minus x. They give you the Ka to be, oh, isn't this the one I said I was going to skip? 0.011. Well, you guys know what to do from here. Normally, they're not going to give you quadratic, but we can think about what we would do if this wasn't quadratic. You would just do a small approximation of your x, multiply it, solve for x, take the negative log of that, and you'll get your pH. We're not doing this problem. I just wanted to show you how you get to that step. All right, let's move on to 30. For 29, don't worry about it because it's not going to be on your test. I mean, if you really want to know, it's C, but you don't have to worry about it. Okay, number 30. Which ion will form a basic solution when dissolved in water? Not C. D. Okay, let's think about it. These are all conjugate bases, right? Br minus is a conjugate base of what? Of HBr. And what is that? Strong acid. And this would be pH neutral. You have NO3 minus is a conjugate base of what? And what is that? So that would also be pH neutral. Then you have HSO4 minus, which is a conjugate base of what? And what is that? Strong acid, making this also pH neutral. I mean, your answer would have to be D, but let's just look at it. So you have SO3 2 minus. What is that a conjugate base of? H, SO3 minus. What type of acid is that? Weak, making this what? Or weak, yeah. So your answer would be D. And there's a good, they have more problems like this in the book, actually. It's one of the example problems in the chapter. All right, I'm just going to scroll up. So you have 31. Which compound will form an acidic solution when dissolved in water? All right, so you have NH4 and Cl. That breaks into what? All right. This is a conjugate of what? NH3. It's a conjugate acid. This is a conjugate base of what? NH3 is weak or strong? Weak base. This is strong or weak? So this would create what type of solution? Acidic. Your answer is A. B, you would have NaCl, be Na plus and Cl minus. This can create NaOH and HCl. What are these? They're both strong, so it would create a pH neutral. Same with C. It would be KOH. No, just kidding. Not same with C. C would be KOH. Let me just write it. It's not Cl minus, it's NO2 minus. So you have KOH and HNO2. KOH is what? And HNO2 is a weak acid. So this would create a basic solution. Question? That was for the last problem, yes. For what? For this one? The first one? You have a strong acid and you have ammonia. Ammonia is a weak base. So this would create, if this is in solution with each other, this would be acidic. We're looking at a solution. Before, we were looking at one compound. So this is where these two questions are different. So for the first one, you're looking at what is it a conjugate base of? If these were conjugate acids, you would do the same thing. What is a conjugate acid of? For 31, though, when it's a compound, you're looking at what would that solution create. So that's where these two problems differ. And that's why I put both of them so you guys can see. And there's a lot of problems in the chapter, too, and they're example problems, so they work it out for you in that chapters for you guys can look at. All right, number 32. This one's kind of long. So we want to know the pH of 0.175 molar NaCN solution, and they give you the Ka for HCN. So you have NaCN, and we always put this in water. So we're putting it in water, and you're at equilibrium with NaOH, right? Am I confusing myself? Yeah, I don't know what I'm saying. HCN and OH minus. Yeah, it would be NaOH, but Na is a spectator, leaving you with OH minus. This is a spectator, so you can ignore it. And this is looking very confusing, so let me erase it. So you have Cn minus plus water yields HCN plus OH minus. So we're going to do an ice table because we want to find the pH. So you have 0.175 molar of this. So our K would equal x squared over 0.175 minus x. They give us the Ka, though. What type of solution is this? Basic. So we need to change your K to a Kb. So we know Kw equals Ka times Kb, which equals 1.00 times 10 to negative 14. So then we can do 1.00 times 10 to negative 14 divided by the 4.9 times 10 to the negative 10 to give you your Kb. Your Kb will then equal some number. It would equal 2.0408 times 10 to negative 5. So then you'll find your x, which equals your OH minus concentration, to be 1.8898 times 10 to negative 3. If you take the negative log of this value, you would get POH. Your POH equals 2.7235. So 14 minus POH will give you pH, and your pH will therefore equal 11.28. And so when you're doing this problem, you would have noticed that you had to change your Ka to the Kb because this was a basic solution. The minute you've done that, you should have went back to the problem and crossed out everything that was acidic. So it couldn't have been A and it couldn't have been C. So your answer is B, 11.28. Are there any questions regarding number 32? Yeah. Doing 2.040 times 0.17. Do a small approximation, solve for x.
Say too soon on the ACS, you can usually do that system.
Always, yeah. Yeah. They're not going to give you quadratics. So always do a small approximation. All right, we're going to move on because it's 6:38 and I have so much. All right, 33. Which acid has the largest Ka? Yes. Answer would be A. 34. Hmm? A buffer is 0.1 molar in NH4Cl and 0.1 molar in NH3. When a small amount of HBr is added to this buffer, which buffer component will neutralize this added acid? It should be C, NH3. NH4 plus is what? A conjugate acid. Your acid's not going to neutralize an acid. So it needs to be a base. Cl minus is not a part of the buffer. So it can't be B. So the answer would have to be C, NH3. 39. You have, I did this in tutoring one day, but 3 15 milliliter acid samples are 0.1 molar HA, 0.1 molar HB, and 0.1 molar H2C. They're all titrated with 0.1 molar NaOH. If HA is a weak acid, HB is a strong acid, and H2C is a diprotic acid, which statement is true for all three titrations? Answer yes is D. They will all have the same volume to reach the equivalence point. What is the definition of equivalence point? Moles of acid equal moles of base. So it's not going to say that this isn't same. There's not a specific amount of volume needed to get to the moles of acid equals moles of base. So that means 33 or 39 would be D. 40. You want to calculate the molar solubility of lead to bromide. I'm going to do it quickly because I want to just finish. So you have PbBr2 is a solid that disassociates into Pb2 plus and 2Br minus. You're doing ice table. You have 0 plus S plus 2S, S and 2S. Your KSP would equal S times 2S squared, which would equal 4S cubed. And they gave you the KSP to be 4.67 times 10 to negative 4. So your answer should be B, 0.0105. 2S squared, so 4S squared times S would be 4S cubed. 41, question?
What's the formula for KSP? Like just like the basic one?
That's the same. K, all Ks are the same. Ks are products of reactants, right? But KSP, it will always be just the products because your reactant is a solid. Does that make sense? So it'll always just be the products. All right, 41. Which buffer system is the best choice to create a buffer with pH equals 7.2? So it can't be strong acid, strong base. I don't think there's any of those anyway. You have a weak acid and its conjugate base of potassium acetate. You have a weak acid and conjugate base. You have a weak base and conjugate acid, and a weak acid and its conjugate base. What do you guys think the answer would be? C. It's the only one that's different. But also, buffers of bases would have a buffer closer to 14, and buffers of acids would have a buffer close to 0.
Wait, why is it C again?
You have a weak base and its conjugate acid. I was explaining. Buffers that are bases will have a pH greater than 7. Buffers that are acids would have a pH less than 7. For the, yeah. Okay, 42. Which statement is true for the freezing point of liquid water below 0 degrees Celsius? Delta H. I can't do delta on Word. Okay. Delta, D is delta, guys. D is delta. All right, so freezing of liquid. For delta H, and you're freezing. Oh, freezing. Is that exothermic or endothermic? Exo. So your delta H would be what? Negative. So it can't be A, Can't be C, can't be D. Answer is B. Huh? Delta H is negative because it's freezing. Freezing is exothermic, making it delta H negative. Already we have the answer B. You can keep going and look at it later to see why delta S and delta G. Freezing in liquid water is spontaneous, so that's why delta S would be... No, freezing in liquid water... I feel like this question is wrong. I think delta S is supposed to be positive. Yeah. So the answer would be correct if delta S was positive. So just fix that on your paper. I'm just going to tell you guys the answers for the rest of them. And then if you see one that you want me to go over, I'll go over it. Sound good? 43. Answer is B. 44. The answer is D. 45. Answer is C. 46. The answer is D. 47. The answer is C. 48. The answer is D. 49. The answer is A. 50 is C. 51 is C. So what questions from all of those? 43? 43? You know your delta G. What is it equal plus?
RT.
Thank you. RT ln Q. Yes. So if your Q is smaller than 1, your ln would be negative. Does that make sense? So for B, it created a negative 6 point something. So that has more likely a chance for making this delta G negative versus if you found this to be positive. So that's how I got the answer. Yeah.
What equation that matches that relates its energy involves N? And then in this equation, RT is the first one, is that negative RT?
Yes.
What's the R value? Like is that 8.31?
8.314. All right, someone said 49. This is from the book. This is this was from a book problem. The zinc 2 plus electrode has a standard electrode potential of 0.76, negative 0.76. We want to know how does this relate to the potential energy of an electron at the standard hydrogen electrode. So this is just it. The answer would be that it would have a higher potential energy than at the standard. This is, yeah, something, it's in the paragraph, yeah. Yeah. Okay, any other questions? Huh? Oh. 51 is just gamma. I don't know my nuclear. I'll do, this one will be my last one. And then you guys will be good to go. And then make sure you guys fill out that survey and then just pass it back to the end of the row so I can collect it. Oh, I definitely covered the whole problem. So amperes equals 1 coulomb per second. Volts equals joules per coulomb. Faraday's constant equals 96,485 coulombs per molar. Electrons, copper to chloride to copper. This oxidation state would be -1, making this +2, and this is 0. So the exchange of electrons is 2. Chlorine is -1. Halogens are -1. If there's nothing else that you can look for, halogens would be -1. Okay, so we're starting off with our milligrams. You have 111 milligrams. You want to get to grams. Milligrams will cancel. Your molar mass will cancel the grams to get you to moles. Then you can get to moles of electrons, 2 moles of electrons. You can cancel the moles of electrons out with Faraday's constant. And then amperes is coulombs per second, so 3.8 coulombs per 1 second will leave you with seconds. Your milligrams will cancel, your grams will cancel, your moles will cancel, your moles of electrons will cancel, your coulombs will cancel, and you'll be left with seconds. Sorry, that was a lot, I know.
How prevalent of this is on the ACF?
They'll have this question. I love this question. It's just dimensional analysis. Think back to Chem 1. You're just canceling out your units. Last thing I want you guys to know, your standard what is it called? Your node, this is the metal, this is the ion, this is the salt bridge, this is an ion, this is the metal. It's always written anode to cathode, and this is your salt bridge. Just letting you guys know because they could have a question written like this, and you'll have to be able to write your write the equations.
For the schematic, the platinum would be written if they were both ACH, correct? Like if the platinum was at the end.
Platinum, they would add platinum if they didn't have a metal. They'll sometimes put a metal if there's no metal.
What kind of question would be asked about that?
Any question?
Like, I don't know. Like, what's that?
It's just cell notation.
Yes.
It's in the book. It's in that.